Alright, today's lesson is lesson number 68. We're going to be continuing factoring trinomials when, specifically when we have a coefficient that's bigger than 1, so when our a term is bigger than 1. This lesson incorporates Math Practice 5, which is to use appropriate tools strategically. Remember, our Xbox is one of our tools that we can use, and we'll be using it in this lesson to factor. So moving on, here are the steps. Again, these are the same steps from the past 2 days, so you don't need to copy these. The A goes here, though, and A, C, and B, in case you've forgotten, and the factors go there. Today we're going to talk about some cases where maybe we can't find those positive or negative factors that add up to B. Okay, so maybe there may not be a set of factors that give us the correct B. So if we've tried all of them, if we factored AC completely and there's none that we can find, we would say that it's not factorable. So we'll see how that looks today. Okay, looking at number 1, first thing I'm going to do is see if there's a GCF. It looks like there is not one, right? 2 goes into 6 and 20, but not 5. 5 goes into the 5 and the 20, but it doesn't go into 6, so I can't pull anything out there. So I'm going to go ahead and make my Xbox and set it up. I have my A term going on the top of the line, so 6 and 6. 6 times the negative 20 gives me negative 120, and then negative 5 goes below. Now I'm going to look at my factors of negative 120. I'm going to think strategically here, right? I want a negative and a positive because I need to multiply to a negative. Specifically, though, I want the negative number to be bigger because when I add them, I want to get negative 5. Okay, so that tells me that I need to have a negative number that's bigger than my positive number. So here are the factors that I came up with. So I have 1 times negative 120, 2 times negative 60, 3 times negative 40, 4 times negative 30, 5 times negative 24, 6 times negative 20, 8 times negative 15, and 10 times negative 12. Okay, I know that that's all the factors that I can do. Okay, I have 1, 2, 3, 4, 5, 6. I can't divide that by 7. I have 8. I can't divide it by 9. And then I have 10. I can't divide it by 11. And then if I go back to 12, I'm circling back through these same factors, right? So that's all of them. And now I'm going to check. If I add together negative 12 and 10, I get negative 2, so that's not it. Negative 15 and 8, I get negative 7, that's not it. Negative 20 and 6, I get negative 14. Negative 24 and 5, I get negative 19. Here I get negative 26. Here I get negative 37. And I'm just getting bigger negatives now, right? Negative 58 and then negative 119 at the top. So I don't get this negative 5 anywhere, right? So that tells me this must be not factorable. Okay, then moving on to number 2, I'm looking for a GCF. I see that my greatest common factor here is going to be 3, so I factor that out. I have 3 times x squared plus 2x minus 8. Okay, that's what I get when I divide each of those terms. Remember, if you're feeling confused here, if this isn't making sense, go ahead back to the lesson from a few days ago that talked about factoring out the GCF. That would have been last Friday's lesson. Okay, so we talked about identifying the GCF last Thursday. So we would identify that 3 is the greatest common factor, and then last Friday we actually factored it out by dividing each of the terms by 3. Okay, so I'm left with x squared plus 2x minus 8. Okay, I'll make my Xbox now and fill in my A is 2, or sorry, my A is 1, so I put the 1 on top of the line on either side of the X. And for this Xbox, I'm just focusing on this trinomial in here, okay? I'm kind of ignoring the 3 for now. So just focusing on x squared plus 2x minus 8. So then I do 1 times negative 8 for my AC, that goes there, and then 2 goes down below. Okay, now I'm going to look at factors of negative 8. I want ones that add up to 2, so I want a negative and a positive, and I want the positive to be bigger. So I have 8 and negative 1, or I have 4 and negative 2. Those are my only factors in this case. And I can see that 4 and negative 2 give me exactly what I want, which is 2 when I add them together. Looking at the fractions now, I'm going to see if I can simplify these. I can't simplify either one, so I will write my answer as a factored expression. So I have x plus 4 times x minus 2 from my x box. And then we can't forget about the GCF that we got earlier, so that gets multiplied in front. Okay, so basically we factored out the GCF and we got this, and then we rewrote what's in the box as this factored expression. Okay, so that 3 still needs to stay there. Okay, moving on, number 3 and 4. Number 3, the GCF here is going to be 4x. Okay, not just 4, both terms both have an x also, so I can factor that out. When I divide, I have 4x squared divided by 4x, which just gives me x because the 4's cancel out, and then one of these x's on top will cancel with the one on bottom. So I get x. Okay, then my second term, I have negative 12x divided by 4x. That's going to give me negative 3 because the x's cancel out. Okay, so that's my answer there. I can't do an x box with x minus 3, right? I don't have a squared term, so I'm just done. I can't factor that any further. Number 4. First thing I'm going to do is look to see if there's a GCF, and I don't see one here, which means I'm going to continue on and start to factor. I put my 3 here. I multiply 3 times negative 4 to get negative 12. And then I'm looking at the factors of negative 12. I see I have 4 times negative 3. And those add together to give me 1, so those are the factors I want to use here. And I'm looking at these, at the fractions. Can I simplify these? The first one, I can't simplify, right? It's 3/4. Can't simplify that anymore, but the second one, I can simplify to 1 over negative 1. Okay, so my factored expression would be 3p, remember, check your variable, this is p here, not x, so 3p plus 4 times p minus 1. And it's okay if I write it in this order as well. That's fine. Okay. Alright, moving on to numbers 5 and 6. I'm going to try to factor number 5 using a X box, my tool, right? So put a on either side. A times c gives me negative 9. And then I put b down below, it's just 7. Negative 9, my factors are 1, my factors of negative 9 are 1, negative 9, and then 3, negative 3. I could also look at negative 1 and positive 9. Right? 1 and negative 9 gives me negative 8. 3 and negative 3, adding those together, I get 0. Then negative 1 and positive 9, if I add those together, I get a positive 8. So none of these are the correct factors. That means my fraction, or my trinomial here is not factorable. Okay, moving on to number 6. Excuse me, I have a GCF of 3. So I'm going to factor that out of each term. That gives me 2x squared here minus 6x, okay, dividing the 3 out of each of these terms, okay, then minus 5. Okay, now I'm going to take the trinomial that's in the parentheses and try to factor that. So I have 2 on either side here. 2 times negative 5 gives me negative 10. And then my b goes here, so that's negative 6. Now I'm going to look at factors of negative 10. I have negative 10 and 1, or negative 5 and 2. I could also put the negatives on the other numbers, but I know that I want the negative number to be bigger here because I want them to add to negative 6. But I can see that if I take negative 10 plus 1, I get negative 9, and negative 5 plus 2 is negative 3. So this is not factorable any further. The trinomial inside the parentheses isn't factorable, So my final answer here, if it said factor, I would give them the answer here in the box. Okay, because that's, it's somewhat factored, right? I factored it as much as I could. I took the GCF out, so it is partially factored in that sense. But I wasn't able to factor it any further because that trinomial is not factorable. All right, so the next thing we did was talk about what we learned and how we do that. So we talked about how we learned to factor trinomials when a is greater than 1. And specifically, we talked about the new ideas of when trinomials are not factorable or when there's a GCF that we can factor out. And we do that by following the steps. So we identify the GCF and then set up an X box, placing the coefficients in the appropriate places. Then we look for the factors of AC that add to B, simplify the sides of the X, or the fractions as we call them, and then rewrite our factored expression. Factoring fits into math because it uses a lot of different tools, or a lot of different skills in order to use this tool. So we have to know how to factor numbers, right? We looked at factor trees. We need to be practicing our multiplication and division. And it's also related to trinomials and quadratics, right? It's the opposite of multiplying using the rectangle. Remember we talked about that, how factoring is the opposite of using this and multiplying binomials this way. So there's that. And as far as using this concept in real life, factoring is used a lot in physics, or we can use it to calculate the time that it takes for something to fall, or if a ball is thrown, we use it to calculate the time that it would hit the ground. So factoring is involved in that. Anyways, moving on. So after this, we worked on some independent practice problems. If you want to pause here and try to test yourself, make sure that you're understanding this concept. Go ahead and do that. Give a few of these a try. All right, and then I'm going to go ahead and click to the answer. So these are the solutions that you should have gotten. Okay, so paying attention, 4 is not factorable. And then these, you have the GCFs that you should have factored out. Okay. All right, so that is all for today's lesson. Thank you. See you guys tomorrow.